Welcome to video 11 of Gamer to Game Developer Series 1, and this video is about fake crouching. So we only have one objective for this video, and that's to implement fake crouching. So this video will be a lot shorter than a lot of our previous videos, and a bit more relaxing too, so it'll be a nice change. So all it's about is that when the player presses their left control key, our player will rescale themselves so they'll become short and squat, and the player's movement speed and jump height will be reduced while they're crouched. So quite simply, we'll write a new script called the crouching script, and when the player presses their left control key and holds it down, it'll change the scale of the player, and it'll access the character motor script and change the player's speed and jump height. And our movement update script will also see that the player's scale has changed, so we'll also edit the movement update script to update the player's scale across the network. So our first step will be to create that crouching script. The first thing I'll do is to define the input for crouching. So over in Edit, Project Settings, Input, I'll change the window shake Y. We don't need that, and at the moment it's a window movement is the type. We'll change that to key or mouse button, and I'll change the name from window shake Y to crouch, and I'll change the positive button to left control. And the case does matter, and the spelling too, so I wrote it wrong there, so let me just press enter. Alright, if it's accepted it'll remain. So left control is the positive button. Alright. So now that I've just named that control, now let's create a new script. So create new C# script, and I'll call this one crouching. And open it up in MonoDevelop. Okay. Now of course, as usual, the summary is the first thing. So this script is going to be attached to the player character, and it allows them to do, well, fake crouching. And, well, all the script really does, it changes the Y scale of the player, and it changes their movement speed. So really this video is more of an excuse for us to play around with scaling. So right here, this script is attached to the player character and allows them to do fake crouching. And, well, the script really just changes the player's Y scale and changes their movement speed. And the script that's accessed by this one is the character motor script. So this script accesses the player's character motor script to change the player's movement speeds, and their jump height. So of course when they're crouched they shouldn't be able to jump as high. Okay, so the next thing to do is to define our variables. And I'll copy the variable start and end lines. And the first thing I'll write here is a comment that, just have a quick reference. Have a quick reference to the character motor script. So have a quick reference to the character motor script. So private character motor. And even though it's not appearing there, we can just continue to type it out. So character motor. The spelling does matter and the case as well. And I'll just call it motor script. And then the next one, I'll write a comment here as well, that these set of variables, well, it's crouching and standing height values. So crouching and standing height values. Private float crouch scale is equal to 0.2f. Private float standing scale is equal to 0.4f. And I'll just point out here that this 0.4f is the actual Y scale that the players are at right now. So if I just jump back to Unity and go over to a player, you'll see that their Y scale is 0.4. So when they're crouched, I'll set them to 0.2. Actually, I think I'll set them to 0.19 instead, just a bit below half. Okay, then our next set of variables are for the movement speeds. So crouch and normal movement speed values. So private float crouch speed is equal to 2. Private float normal speed is equal to 5. And then another set of variables, the crouch and normal jump height values. So crouch and normal jump height values. So private float crouch base height is equal to 0.5 f. Private float normal base height is equal to 1.0. Well, you could just put it as 1. Private float crouch extra height is equal to 0.5 f. Private float normal extra height is equal to 1. Now what this base height and extra height, if you go and have a look at the character motor script, and even when you play the game, you'll have noticed that when you quickly tap spacebar, you'll just jump up a little bit, but if you press spacebar and keep it down, you jump higher than when you just do a quick tap, and that's what this is. So if you just tap the spacebar quickly, you'd get a base height, but if you hold the spacebar down, you'll get the extra height, so you'll be higher up. So we have one more variable to put in, and I'll just go down here and just add space to this and add that new variable used in determining whether the player will be crouching or standing. Public bool crouch engaged is equal to false. Alright, so that does it for our variables. So we'll start off with if network view .isMine is true, then we'll do a bunch of stuff, but else enabled is equal to false. Alright, so the first thing we're going to do within the start function is to set the player's normal speed on spawning. So set the player's normal speed on spawning. So that'll be motor script is equal to, so first of all we'll access that script, is equal to game object dot get component And the component is character motor. So character motor. Then motor script dot movement. Now my autocomplete is not working, so what I can do, I'll just like that out. I'll save the script and close down monodevelop. And then I'll go ahead and open it again. Alright, let's see if it's working now. Motor script dot, okay, so it's working now. So if you come across that problem that you're trying to use the character motor script and you're trying to access it, and the autocomplete isn't working, then just shut down monodevelop and open it again. So that was motor script dot movement dot max forward speed. And by the way, you can actually see these speeds. So if we go back to Unity and you have a look at either player, so let's say the blue player, you can see there within the character motor script, you can see that all of those speed values are actually shown in the inspector panel. So you can see the max forward speed, sideways and backwards, and we're going to set all of them. So let's just jump back. And so motor script dot movement dot max forward speed is equal to normal speed. Motor script dot movement dot max backward speed is equal to normal speed. Motor script dot movement dot max sideways speed is equal to normal speed. And then we'll also adjust the jumping heights. So set the player's jumping heights. So set the player's normal jumping height. Motor script dot jumping dot base height is equal to normal base height. Then motor script dot jumping dot extra height is equal to normal extra height. Alright, so that should be it for our start function. Now going to the update function. We'll have here that we engage crouching when the player presses left control, and they're not already crouching. And of course not using a menu either. So engage crouching when the player presses left control and is not already crouching. And the cursor is not unlocked. If input dot get button down, and that button that we had defined was crouch, and crouch engaged is equal to false, and screen dot lock cursor is true. Then the first thing that we'll do is set crouch engaged to true. So crouch engaged is equal to true. And then The next thing we're going to do is, because we're going to rescale the player, we're going to change the player's scale so that they become shorter. You remember there's something called the camera head game object inside the player, and the camera is following that. So what we don't want to have is a situation where the player can see themselves while the crouching is happening. So that will happen currently if we don't shift the camera beforehand. So what we're going to do now is to actually move the camera down a bit, and so that way when the player is then resized, they won't see themselves getting resized. Otherwise they'd see it just for a fraction of a moment and would look a little bit odd. So the camera is shifted down so that it remains inside the player before the player's scale is changed, and that's what I'll write. The camera is shifted down so that it remains inside the player before the player scale is changed. This prevents the player from seeing parts of themselves when crouching. Well, there's only one part, that's the capsule, when crouching. So game object main cam is equal to game object dot find, and we find main camera. That's what it's called. Okay, so then we'll define a vector3. So vector3, and we're just creating this variable on the fly. Camera pos is equal to a new vector3, and that will be transform.position. So the x value is transform.position.x. So the same x position as the player. Main cam dot transform dot position dot y minus 0.14 f. So just a bit of a value. This will shift the camera down. Transform dot position dot z. Because since we're scaling the player to just slightly less than half their usual height, so that's why we're positioning the camera just below the halfway point on the player. So this will be about right. Okay. Then main camera. So main cam dot transform dot position, it will equal this camera pos. So it's equal to camera pos. Now that we've changed the camera's position, now we can scale the player. So we'll change the player's scale. So change the player's Y scale. Transform dot local scale is equal to new vector3 transform dot lossy scale dot x. Then crouch scale is the Y scale value, and transform dot lossy scale dot z. Now the lossy scale is pretty much saying that's the world scale value. So just going back into Unity, so you see here how it says the X scale is 0.5 and the Z scale is 0.5. So we're pretty much just saying that keep the scale, this X and Z the same, and the Y we're replacing 0.4 with that crouch scale, which was 0.19, which we defined in our variables. Okay. And that should be all right. Okay. The next is that we'll access, so after we've changed the player scale, we'll access the character motor script and change the player's speed and wall jumping height values. So access the character motor script and change the player's speed and jump height values. So motor script dot actually, I've just thought of something. Rather than typing it all out, how about I just copy all of this? I'll save us some time. And I'll get rid of this comment. Okay. And I don't need this line here, since I've already got a reference to that character motor script. So I can delete that line. It's already been done in the start function. So now motorscript.movement.max forward speed is now going to equal crouch speed. And I think I'll just copy that and paste it over these other two. Okay, and now our jumping base height is no longer normal base height, it's crouch base height. And normal extra height becomes crouch extra height. Alright. So that will enable crouching. Now, what about when the player lets go of their left control? So when they let go of the crouch button, then of course we'd expect the player to rescale back to their normal scale and of course be at their normal speed and jumping values. So that's the next thing to do. So outside of this, we'll now do a new if statement. So if I'll write here the comment first that disengage crouching when the player presses left control and is currently crouching and the cursor is not unlocked. So if input dot get button up, crouch is the button, and crouch engaged is true, and screen dot lock cursor is true. So then what will happen is that first thing is crouch engaged. We'll set it to false. And then what we're going to do is to boost the player up a bit. Because you see when they're scaled down, when they're short and squat, if we rescale them at that point at their current Y position, what'll happen is they'll be partly sticking in the floor. And so then they'll just drop through the floor of the level. So what we need to do is just before we rescale them, we'll bump the player up, we'll move them up, and then rescale them. So then when they just rest down a little bit, they'll be on the floor of the level. And they won't really notice that. So boost the player up a bit so that they can't fall through the floor when rescaling. So transform dot position is equal to a new vector3 transform dot position dot x. So keep the current x value, the one we're changing is y. Transform dot position dot y plus crouch scale. And then the z position is the same, so transform dot position dot z. Okay. And of course close that bracket. So after we boosted them up, then we rescale the player. So rescale the player to their standing scale. So transform.localScale is equal to a new vector3 transform.lossyscale dot x. The y scale will change to standing scale, and the z scale will be the same, so we use transform.lossyscale.z. Okay, so then the next thing, once again, I'll just copy paste all of this right here, accessing the character motor scripts, and change the player speed and jump value heights. So copy and just paste it in. And now the max forward speed is once again the normal speed. So normal speed, and I'll just copy paste that over these crouch speed. Okay, and the base height for jumping is now not the crouch base height, it's the normal base height, and the crouch extra height is now the normal extra height. Okay, and that should be it for our crouching script. So let's save it, and we're not done yet. We need to now go and update the movement update script, so that way when the player changes their scale, the movement update script will send out RPCs across the network, so that changing the player's scale across the network. So let's just have a quick check in Unity. I've saved it. Let's just check that there are no obvious errors. Okay, no, that's good news. Okay, so we can move on to the next step now. We're on to step 2 now, which is to edit the movement update script. I've opened up the movement update script, and we don't need to make too many changes to this. First of all, let's go down to the RPC, and I'll write a comment here for it now, that this ensures that the player's position, rotation, and scale is kept up to date on every other player's computer. So I'll write here, ensures that the player's position, rotation, and scale are kept up to date across the network. And we're going to add here that it requires another term here. It's vector3 new scale is what I'll call the variable. So it's now going to require a vector3, and that'll be used to scale the player. So transform.localScale is equal to new scale. Okay. Now let's modify our RPCs so that a scale value is provided, a vector3. So now we'll supply myTransform.localScale. That's all we need to give it, and we can just copy paste this, and wherever the RPC is used, we'll put this in. So right here as well. And also here. So this one was when the player has moved a distance, so then we send out an RPC, and this one is where the player has rotated a bit, and then we send out an RPC for that as well, to update the player's position, rotation, and scale across the network. It's probably not necessary. When I think about it, it's not necessary to send out so much information, especially if the player is just rotating, but in this case, it's such a small amount of data, and it's just a small multiplayer game that we can get away with this sort of inefficiency. But really, if you're going to have a lot of players, like maybe you're going to have 20, 30 players playing, then I should really be more efficient. I should target what I actually need to send and when I need to send it. So in this case, since the player has moved a distance, do I really need to send the player's rotation across the network? Probably not. And Do I really need to send the scale either? Maybe I could just have it monitor the player's Y scale. But then again, it's a small amount of data as well, so perhaps it's not a big problem. Okay, that's all we needed to do to this script, so let's save it. And we can probably jump over to Unity and attach that crouching script. So jump over to our blue player. Let's attach that component scripts crouching. Okay. And then also for our red player, component scripts crouching. And we can file, build, and run. Now, an important thing to remember is that in the editor, crouching won't work. It'll only work in the standalone windows. So certain keys, like if you had assigned numerical keys, the 1, 2, 3, 4, 5, you'll find that in the editor they won't function because they're already assigned to something else. And the control key also behaves like that too. I find that if you press control, what you had programmed is not going to happen like that in the editor. You actually need to run it in the standalone game. So let's launch it. We only should need one copy. So the editor I'll use as the server. So I'll just connect, set up a server, jump over, connect as a red player. Okay, and we can see the red player there. Alright, so I can move, and yes, there you go. You can see in very small. Let me zoom in. So let me escape from there and zoom in on the player. Okay, that's much better now. And let's focus. So once again, let me just minimize this a bit. We'll decrease the size. Go back and return to game. And there we go. We can see that the player has become short and squat, and we can jump. When we move around, movement is much slower. The moment we let go of left control, suddenly the player is zooming around and we're a lot faster and we can jump, etc. Which is good. Okay, so let's try that with the blue player as well. So connect as a blue player. And let's see how the blue player fares. Yep, and they're working as well. So as you can see, the player is crouched. I don't know why I'm shooting there, I guess because there's nothing else to do at the moment. Okay, so that's it. Our fake crouching is working. And when we hold down the left control, quite simply, our player is rescaled. And our scaling is working too when the player comes from their crouched position to the standing position. They're boosted up a little bit. You can't notice that effect at all. But we do that so that way the player doesn't fall through the floor of the level. Okay, so this was a really quick video, as I had mentioned in the beginning, and it was pretty relaxing. It was just really an excuse for us to play around with scaling. Now, to actually make it useful, if you had a model, if you actually had a player model, and that model has animation for crouching, then you can still use the crouching script. You'd have to heavily modify it, but you'd include, I guess, your animation portion of the code where the player is getting scaled. So instead of scaling the player, you'd just make the player change their posture. And of course, you'd need to also tell that across the network, so the other players would also see the player in the crouched position as well. Okay, but that's it for this video. So thanks for watching, and I'll see you in the next video, which will be much more exciting, which is the video about blinking or teleportation. That's a really interesting topic. Alright, so see you then.